Welcome to class, everyone. This is week 12. This will be April 5th through the 11th. We're on the downhill side. Really, the last big things we have to do are the human subjects review, and you need to turn in your chapter 2 this week. And then by April 25th, you need to turn in your chapter 3. I think everybody's doing great. So just want to reassure everybody that we're going to make it through. This has been the craziest semester you've probably ever had in your life. It's been really weird for me too, so I know how you feel. But first of all, I would like to go over one thing about the chi-square when we did the assignment where it was talking about men and women and their preference for buying cars, because there was something I wanted to clear up about that assignment for you. So just 1 second. And let me close PowerPoint and let's go over here and talk about this. So we know on the assignment, I'm sorry, I don't know why my voice got raspy all of a sudden. When we talked about this assignment right here, we talked about just taking and adding straight across. So you know you had 350 men and 300 women, so we just divided by 3. But to get the actual, honest, real expected values, it's a little more complex. For this assignment, we took it kind of the easy way out. But if you were to use this in an actual paper that you were going to write, you can use a chi-square calculator online that'll give you the expected values, or you can actually figure them out yourself. So the first thing you need to do is add both ways. So we have the totals 350 and 300, then you have to add these. So these come out to 225, 225, and then 200. That gives us a grand total of 650. To figure it out, you follow the same step each time, but let's start with the men first. And we're going to say for appearance, you take the 225 times the 350. Okay, so you got the 225 times the 350, which is 78,750. Once you get, I guess it would look nicer if I put an equals in there, wouldn't it? Once you get that answer, you take that answer and you're going to divide it by the grand total, which is 650, which will give you an answer of 121, 153, 846. So we would leave that at 121. So for your first category right here, you would put 121. And since I know y'all are all really great at math, you can tell if it's 225 right here and it's 225 right here, obviously this is the same answer. So that makes life simple. So now we come to the cost. You do the same steps over again. You do the 200 times 350, which gives you 70,000. You divide it by 650, and you would get 107.6, which we would round up to 108. And you do the same thing for women. This time it's the 225 times 300 divided by 650, which will give you your answers for that, which are 103.8. And since it's 0.8, we will round it up to 104. Again, it's the same answer because it's the same number at the bottom. And the last one is 92. You can see they're very close to what we put down when we just did it the simple way. But I just wanted to bring this up to you so that you would know that if you are really going to use this for a statistical analysis, it's a little bit more precise way to figure out the expected values if they're not given. So when you come over here to your Excel spreadsheet and you do this, you see that you have your cost, your actual here, you have your expected here, and then when you click, you'll get your answer. And you see that this is a little bit different than what we got when we did it the way we did in class. I don't think I have it in front of me right now. Let me see, we got I think we got 5.17 to the e to the negative 17, and this is 1.028 e to the negative 16. But they're both such infinitesimal numbers because, you know, if you take this out of scientific notation, that e to the negative 16 means you move this decimal over 16 places. So there would be 15 leading zeros before you get to the 1. But that's how you precisely do it. And I just wanted to explain that to everybody, just in case you do decide that you want to use this, that there is a more precise procedure for doing this kind of calculation. All right, so let's go back to our PowerPoint. So for our homework for assignment number 9, our first question was to do the Pearson's R for the following data, and it was hypothesis 1 is workers who score well on safety instruction will score well on a job satisfaction survey. Compute the Pearson's R. You should have gotten an R value of 0.82, and the P value is 0.023. R to the pardon me, R with 5 cases is equal to 0.82. P is equal to 0.05. Therefore, we do accept our hypothesis. Now, this number right here, this R value, is our level of magnitude, and we will say this is a very strong relationship. Let's jump over here and look at the Excel spreadsheet on this to see exactly how we did this. So in the spreadsheet, we have the X and Y values for these workers. So what we do is we go to data, and we go to our data analysis, and we go to regression, and we want to enter, and this may be wrong because the last time I did it, it was somewhere else. Let me try that again. So we can enter the labels if we want to. And the thing that's a little tricky about this is that you do it backwards from what you think you're supposed to be doing. You pick the Y value first. So since I do have a label, I'm going to pick the Y value right here. That's the, well, shoot. The Y value goes right here. Then we're going to input the X range. This is the X range over here. So look at it. You got B. You got your labels, and you can have your output on the same sheet, or you can go to a different area. I'm just going to put it right here. So we'll have a range and say OK. And you will see these are the data points that we used. The residual, we had that. We had our multiple R, which is 82. So if we go back to our PowerPoint, we will see that our R value was 82 and the P value is 0.023. I know we're doing a lot of jumping around, but I'm trying to help you with this. So here is your significance level right here. Sorry, I should have done that. Your regression, your significance level 0.023. So we can tell that this is the 5. The R with 5 residual is 0.82. Therefore, we can accept our hypothesis. The next thing we want to talk about is our Spearman's rho. And this was for question number 7, talking about sprinters versus hurdlers. So our rho value comes out to be 0.025, and our P value is 0.93. And that is definitely higher than our level of P is less than 0.05. So we reject the hypothesis. But let's go look to see how we figure this out. It's a pretty easy thing to do. You go to this web page, socialstatistics.com, and you enter the values. The X values we'll call the sprinters, and that's 1 through 15. And then the Y values are the hurdlers. and you see their values are entered. Once you enter them in, you click calculate, and it will tell you that the value is 0.025, and for a two-tailed analysis, your P is equal to 0.92953. So by normal standards, the association is not considered significant. So we know that that is not significant, and we can reject the hypothesis. So now that we can put statistics behind us just a little bit for a few minutes, let's talk about what we need to have for our Chapter 5. So we've talked about the contents of Chapters 1, 2, 3, 4, and 5. You do not have to do 4 and 5 in this class, but at some point you will have to. So this chapter is really a chapter that is considered one that's able to stand alone all by itself. It doesn't need to have the other chapters. If somebody just picked up a Chapter 5 and read it, it kind of re-emphasizes everything that was originally presented in the first 4 chapters, just in a more concise way. So in Chapter 5, we have some major categories. One of them is the summary, which obviously summarizes everything for you. You have conclusions. What are the things that, based upon your research goals, what are the things that you were able to conclude from the analysis or the data study that you performed? And then, last of all, you make recommendations. If someone else wanted to try to do the same study that you had done, what would you recommend they would do? What are some ideas that people could do to make a future study or to take this data and study it in a different way? So your summary has some major categories to it. First, it goes back and restates the problem. It also restates the research goals you had. Why is this significant? What are your limitations? The population, the instrument, how you collected your data, and how you're going to analyze it. It's very short. It's not very long. Now, when I did mine for my dissertation, obviously it was a lot longer, but for this, for a master's thesis, it's not as long. But it's basically a recap of what was in Chapter 1. So I cut out a page of my dissertation just so you could kind of see how it's lined up and what you do. So you have summary, conclusions, and recommendations, and you go down and you list the things that are relevant to your study. Conclusions. Now, you have to repeat all your research goals. If you have 2, that's all you have to repeat. If you have 4 or 5, you have to repeat each goal separately and then provide an answer that you found to each of those. And these answers are based on the data that you collected. And the conclusions report the data, the numbers, and you say, this is what's important about what I found. If at all possible, you should support your conclusions with references from other sources, because this makes your study stronger. It makes your data analysis more valid and more reliable. And here again is a sample of some conclusions so that you can see how it was reported. And you see there are some references in here. Recommendations, these are things that you're saying, after I've analyzed the data, this is what I think should be done with this data, and other studies that might be able to take this data and do something else with it. So here you see some recommendations and interpretations of the data. So we're going to have a little bit of a review about the entire project. Now we got all 5 chapters and we want to put it together. You have to have a title page, an approval page. Those are the people who have helped you with this. It may be just your advisor, a table of contents, a list of tables, a list of figures. So here's an example of a table of contents, again from my dissertation, because that was the easiest document I could get my hands on. If you can use the table of contents feature in Microsoft Word, it will make your life much easier, because if you get down here and decide you need to move this to a different place, it can mess up all your numbering if you do it manually. So try to explore using table of contents in Microsoft Word. It makes life easier. But you see here we have the dedication, the acknowledgments, the list of tables, and the list of figures. Then at the very end of your project, you will have all of your references that you have cited in the body of your project, and any appendices, if you have any, will be here at the end also. So here is a cut from some references that were cited. This is an older version of APA, so don't look at this and think it's gospel, because it's what was gospel at the time it was done. And here's an example of Appendix A that was included. This was when we did the pilot testing to ensure that it was covering what we wanted it to. Even though we're not going to do the test 3, some things that you need to review so that you don't forget. What are the components of chapter 4? What goes in chapter 4? You have a title of the chapter, then you have the components, the organization, and tables and figures. Remember the 4 types of data that we deal with when we are doing any type of statistical analysis. Those are nominal, ordinal, interval, and ratio. And then we talked about our measures of central tendency. And you remember the mean. The mean is what they call the arithmetic average, or it's the average of all of the numbers divided by the number that you have in your data set. The median is the number that's in the middle. First, you have to put the numbers in order from lowest to highest or highest to lowest and find the number in the middle. If you have an even set of data, like an even number, you take the 2 numbers that are in the middle, where the middle would be if it was an odd set, add them together and divide by 2. Mode is the one that occurs most frequently. Remember the measures of variability that we talked about and learned. The range is the difference between the most extreme scores in the distribution, or the difference between the highest and the lowest score in your distribution. So the range, you subtract the lowest from the highest. For variance, it is an average which reflects the distance of individual scores from the mean of the distribution. It deals with the spread of the data or the dispersion of the data. And then the standard deviation, we figure that out by computing the variance. It's an extent of the degree to which the scores do or do not cluster around the mean of the data. So we talk about when would we do certain things. When would you do a t-test, and what are the steps for doing a t-test? Remember that you do a t-test when you are trying to compare the means of 2 separate sets of data. And then the steps that you do to do this, remember we went over those. You can review those in the lesson 9 when we did that. The chi-square, when do you use a chi-square? Remember, you use a chi-square when you are trying to analyze or trying to correlate and look at the differences between the observed frequencies and the expected frequencies. And what are the symbols that we need to remember, the things that we need to know when we are trying to look at some of these if you see a formula written out? So I put some of the symbols here because we didn't really spend a lot of time talking about the symbols, but they are very important, and they're things that if you can recognize them and remember them, it makes it a little easier on you. And it is like learning a foreign language when you're trying to read through them and make sure that you remember exactly what they stand for. But the mu, or this little Greek letter right here, is the mean of a population. This is the symbol for chi-squared. This is a symbol for standard deviation, or a lot of times people just put SD. X bar means the mean of a sample. The X tilde means the median of a sample. Remember, the big N is the population because it's the biggest number, it's the biggest letter, so it's the biggest group, and the little n is sample. This is the null hypothesis, so that's when you're trying to say there is no correlation. T, the italicized T, is the t-test. R is the linear correlation coefficient of a sample. It's called the Pearson's R. And then this is pronounced rho, and it can be this little Greek letter P, but usually we just use the R like this. And this is the Spearman's rho, and that's a ranked order correlation. So that's the difference with that one. Last but not least, we want to talk about, when do you use Pearson's R? Remember, that is a correlation coefficient. It's a measure of the strength of the association between two variables. So that's when you would use it, and what are the steps for using it. Spearman's rho, when do you use it? It is a test used to measure the strength of association or correlation between two variables. And the Pearson correlation evaluates a linear relationship between the two, but the Spearman correlation is based on ranked values for each variable rather than the raw data. So Spearman's is usually used when you're trying to evaluate relationships that involve ordinal variables. So we get to this one and we say, so what statistic would you use for this? You have a descriptive study, and the question is, what were students' attitudes toward Foundation 612? It's a survey question, and it has this scale right here of strongly agree, agree, undetermined, disagree, or strongly disagree. What statistic would you use? This would be where you would go back to our original statistics, and you're going to talk about the mean, median, and mode. So this is your measures of central frequency, because you're going to find a cluster of data where people have SA or they have D, and so then you're going to find which occurs the most. So suppose you had this one. What statistic would you use for this? Students who complete homework assignments in Foundation 612 will score higher on course assignments. So you have two sets of data. They're not exactly equal, but they're pretty equal. And what would you do with this? This would be a t-test. Young adults who do excessive exercise will develop arthritis after age 50. So you have your exercise group and your non-exercise group, your arthritis and your non-arthritis. The key to this is looking at this table right here, and you know that you're trying to find a correlation between this data. So you would use what test? If you said chi-square, that would be correct, because you're analyzing data for arthritis or non-arthritis, exercise, non-exercise. What statistic would you use for this? Teachers who complete a liberal arts degree will score well on GRE testing. So you have their GPA is the X value. Their Y value is the score that they get on the GRE. Since this is not ranked data, this would be the Pearson's R, because you see these are not in any kind of order. So this is the Pearson's R. Then we have faculty who publish in journals will earn higher merit raises. The first clue to what you want to do this are these two words right here. You see, when these are ranked, then you know that you will use the Spearman's rho to complete the statistical analysis. And now just kind of like, I guess this is like a public service announcement or whatever, but for those of you who are in occupational and technical studies, you will be moving on to SEP 636 during the summer, as far as we know anyway, unless something else changes around here. But if you're taking it this summer, these are things that you need to remember. You should have a fairly good foundation for your chapters 1, 2, and 3. Keep working on it. We're going to talk about human subjects approval next week. Actually, I have some forms for you to fill out, and then you can turn them in to me. And at that point, we will determine whether to submit them to the human subjects, the IRB board here at ODU. If you're in 636, once you get some data collected, then you're going to start working on your other chapters, which are 4 and 5. Dr. Kozlowski has in here that you're going to complete your draft the first week in July for 4 and 5. And so they'll work on that during the summer. If you don't get it done by the end of the summer, then you get it incomplete so that you can keep working on it, which is not unheard of, because sometimes when you're trying to collect data, things don't always work the way you want. I actually remember when I was collecting data for my PhD, I was trying to get parents to turn in, this was back in the old days, paper surveys. And the only incentive that I had, because, you know, this is low budget, you can't afford to spend a lot of money. The one incentive I had was that students who turned them into the office each got a free snow cone that day. So I worked with the middle school principal, and we had snow cones that we handed out to the students for returning the survey. So that little bit of a carrot was enough to get the students to remind their parents to give it to them so they could turn it in. So data collection is not always as easy as it seems. So don't be alarmed if you do have to take it incomplete. It's not the end of the world. As always, if you have any questions or concerns or any of these statistical things giving you a fit, let me know and we can work on it. I'm basically working from home now, although my institution still thinks we need to show up every once in a while, I guess, to earn our money. But I'm basically working at home, so if you need anything, you can call, or we can set up a Zoom meeting. We can do whatever you need to do to make sure that you feel confident about what you're doing in this class. So don't hesitate to contact me, and I will talk to you soon. Thank you.